Hi, today we'll be going through OpenRocket 23.09 in a shorter version. In this video, you'll see what OpenRocket can do. At the end, we also have a very neat surprise for you. Alrighty, let's get into this. Here we have a blank rocket. This is what your screen will look like as soon as you open the program. However, I'm going to switch to a pre-made rocket. In the top left, this will be where all of the components will be. In the top right, here's where you can add components. If it's grayed out, then you need to select an item that it can go under. Body tube can have everything go under it. In the bottom, we can see the rocket as you build it. In the top left of this pane is all of the dimensions. In the bottom left, we have apogee, max velocity, and maximum acceleration. These are statistics. In the top right, we have stability. This is very important, and it should be from 1.5 and onwards. Above stability, we can see the motor. You can change these configurations up here by motors and configuration. Press new configuration and you can find the engines that you want, and you can also make it filtered. You can also delete configuration here. Going back to the rocket design, let's go into one of the components. Up here, I'm going to go into inner tube. I've just double-clicked it. You can change things like length, diameter, and wall thickness. You can also change the placement and material here. The material is very important. In this inner tube, this is where we add the motor. So I go into motor and tick this component is a motor mount. Then in the flight configuration, you can add these and they'll show up here. Once you click them, an engine will show inside of the engine bay. You'll notice as I clicked inner tube, it went bold on the design. The next step is to make sure that everything fits. You can see here that the motor fits. It's indicated in gray. Up here you can see that the nose cone shoulder also fits inside of the body tube. Always check this. You also have a side view on the left. As I rotate this, you can see what changes. Now I'll show you something cool that we can do with the fins. If you've selected freeform fin set, then you can go into it and go into the shape. Here you can optimize the fins to exactly how you want it. You can either drag these points or you can perfectly optimize it here. You can also add points by clicking and control clicking it to delete. We can also change the number of fins. I've selected 4 here, but 3 is also good. I'll change it back to 4. Alright, let's cancel out of the fins. Here we can see the apogee and stability. We can see that the stability is 2.56 and the apogee is 150 meters. This is good. If you have any missing components that aren't in the new component section, then you can press mass component. As you can see in here, there is no altimeter. So what I did was I added a mass component and called it altimeter. In here you can change the mass type to whatever you want, but if it isn't in the mass type, you can just press mass component. Change the mass, length, and diameter, and that should be good. Alright, let's up the mass. Look at the stability as it changes. The stability is getting better. This is because the CG is getting pulled more forward than the center of pressure. They should be at least 1 D apart, and D is diameter. The blue dot is the center of gravity and the red dot is the center of pressure. This will ensure that your rocket is safe to launch. When you are finished with your rocket, you can go up here to File, you can save your designs and you can open old ones, and you can also make a blank page. Once you've saved your rocket, you can go to Flight Simulations. This is where you simulate it flying. Press New Simulation and you can edit everything here. This is things like wind, launch site, and the launch rod. Press Simulate and Plot. Here you can choose what things you want to show. Now I'll press Plot. You can see the graph here. We have things like altitude, vertical acceleration, and vertical velocity. We can see in the orange, we can see vertical acceleration. This is a very, very quick burn. For the yellow line, that is velocity, we can see that it coasted for about 6 seconds. The blue line is altitude. We can see that it got to an altitude of 150 meters. From the apogee, we can see that it slowly drifted down until it hit the ground.
Okay. 5, 4, 3, 2, 1. Oh my gosh, I need to catch that!
Oh my goodness!